Viewers, now we discuss an important topic, Gompertz population model. At first, we consider the Malthus model, and this model is exponentially large and it is ridiculous. That's why we needed Gompertz model. And now, with the help of Malthus model, we needed the help to prove the derivations of Gompertz model equation. We needed the help of Malthus model equations. So at first we consider the Malthus model equation. If y t be the state variable at time t, then dy dt is equal to ry. This is a Malthus model equation. Taking it equation number 1, where r is the growth coefficient of time t, that change with time t, with initial variable, with the initial and according to the relation, we can say that means change with time t according to the relation d at dt, that will be minus alpha dash r. Taking it equation number 2, with initial condition r of 0 equals to r0 and alpha dash is decaying coefficient of r. Now we are going in the solving this equation 2 with using initial value dr by r integral r0 to r, that is minus alpha dash 0 to t dt. So it will be ln r by r0, that will be minus alpha dash t. So r equals to r0 into, it is exponential or e to the power whatever may be, right, e to the power minus alpha t. Taking it equation 3. Now substituting 3 in 1, and that means this equation, and r, that is a cases of r, we obtained as dy dt equals to ry, r0 into e to the power minus alpha dash t into y. Now taking dy by y at y0 to y is equal to r0 into e to the power minus alpha dash t dt, 0 to t dt. So here y0 is the initial condition. Now we get ln y by y0, that will be minus r0 by alpha dash e to the power minus alpha dash t minus 1. So it will be r0 by alpha dash 1 minus e to the power alpha dash t. So here we rewrite the equation once more, ln y by y0, that will be equation r0 by alpha dash 1 minus e to the power minus alpha dash t, which imply y equals to y0 into e to the power r0 by alpha dash 1 minus e to the power minus alpha dash t. In this way we can write with initial condition y0, that is y of 0 at t tends to infinity. Now here in the earlier equations, that means here equation number 3, and if we substituted it, if we take it equation number 4, dy dt equals to r0 into e to the power minus alpha dash t into y. This is called Gompertz equation. So dy dt equals to r0 e to the power minus alpha dash t into y is Gompertz equation, and this equation is a function y equals to y0 e to the power r0 by alpha dash 1 minus e to the power minus alpha dash t is Gompertz function. And taking it equation number 5, say, now if we take from 5 that as t tends to infinity, at t tends to infinity from 5 we have that y tends to y star. So at t tends to infinity, y tends to y star, that will be equals to y0 into e to the power r0 by alpha dash minus y into limit t tends to infinity to the power minus alpha dash t. So it will be 0, y0 into e to the power alpha dash r0 by alpha dash. Taking it equation number 6, now substituting 6 in 5 we obtained y dash y star equals to y0 into e to the power r0 by alpha dash. We can put this type of equations here. So it will be yt equals to, here if we put this type of equations, y0 into this, that will be y star into e to the power into this, that is e to the power minus r0 by alpha dash into e to the power minus alpha dash t. We can write these equations and taking it equation number 7. So the quantity y star is the value of y when t become very large, so it is asymptotic value of y. So y star is asymptotic value of y as t tends to infinity, we get finite value x star of x. That is a fixed value. We get a value, the quantity, we get finite value or finite quantity x star of x. In this sense, it is carrying capacity. Now if we consider this equation, that is y is equal to y equals to y star into this, then y by y star, that will be e to the power minus r0 by alpha dash e to the power minus alpha dash t. So taking logarithm both sides, ln y by y star, that will be minus alpha r0 by alpha dash e to the power minus alpha dash t. So it will be minus alpha dash ln y by y star, that will be minus alpha plus alpha 0 into e to the power minus alpha dash t. R0 into e to the power minus alpha dash by t. So if we substituting this value from Gompertz equations, taking the equation number, here is a Gompertz equation, dy dt equals to r0 into e to the power minus alpha dash t into y. With substituting this value, we get the form, alternative form. If we substituting the value minus alpha dash ln y by y star equals to r0 into e to the power minus alpha dash t in the Gompertz equation, dy dt, that will be r0 into e to the power minus alpha dash t into y, it will reduce to dy dt equals to minus alpha dash y ln y by y star. This is an alternative form of Gompertz equation. And 1 by y dy dt is given by the difference of the logarithm of y star and y. So now we end our discussions of Gompertz model and Gompertz functions. Thank you.